All right, so welcome back. Now we've secured the network perimeter and even hardened our endpoints. Now we need to look to see what runs on those machines. So chapter 8 is going to be all about securing our software. Okay, we're going to be talking about application security. This is layer 5. Even if your firewall and antivirus are perfect, a single flaw in a web application or a database can let an attacker walk right in through the front door. So here's our plan for this chapter. We'll start with the SDLC, the software development lifecycle, and why we need to shift left. We are going to dive deep into OWASP Top 10. We're going to be talking about the industry standard list for the most dangerous web vulnerabilities. You need to know how SQL injection and cross-site scripting actually work. We need to cover the defenses and input validation, and really how to manage third-party libraries. And then finally, we're going to talk a little bit about SAST and DAST. We're going to be checking the code and checking the app itself as it is running. So why is software one of our largest, weakest links? Because applications have VIP data, right? They have the VIP access into our systems and with our data themselves. Your firewall is designed to let traffic in on port 80 or 443 for your web apps. It doesn't look at the traffic itself to see the commands that are actually running. So applications talk directly to the database itself. If the application is flawed, then an attacker can trick it into handing over sensitive data, completely bypassing all network defenses. Remember, firewalls can't stop bad commands hidden inside of good traffic. This is just one of the things that is above it. So how do we fix this? We have to change how software is built. In the traditional SDLC, software developer lifecycle, security was an afterthought. You designed, built, and tested the software, and then right before launch, you asked security to check it. Now, this is very, very expensive. Fixing a bug after the code is finished is like realizing you forgot the plumbing after you poured the concrete foundation. So the modern approach is what we like to call shifting left. We're going to integrate security into the design phase, the build phase, and even the test phase. Bugs found early are cheap and easy to fix. So the OWASP Top 10. To secure apps, you need to know what you're fighting. Without knowing what you're fighting, how do you know what to fix? So we use what we call the OWASP Top 10. This is the most wanted list for all web vulnerabilities. If you work in AppSec, this is going to be your Bible. It basically looks for all of the heavy hitters. And the first up on this list that we always talk about is going to be injection, specifically SQL injection. This happens when an app mistakenly trusts user input and sends it directly to the database. A classic example of this is a login box. Enter your username. But instead of putting in their username, what if they put dash or 1 equal 1? The database is going to see this logic is 1 equal to 1, and it's going to come back and say, yes, that is true. Because it's true, the database unlocks the door, often logging the attacker in as an administrator without a password. Next is broken access control. This basically runs, saying, can a user see user B's data? If so, imagine being able to just log into anybody's account by just hopping around. So imagine you're in a bank account and the URL says /account ID equals 100. That's your account number. What happens if you change it to 101? If the app is broken, it'll just show you the next account, the next person's bank account. The defense here is server-side checks. The server must ask, does the user requesting the ID of 101 actually own 101? If so, okay, we'll let them see it. But if not, This is where we can tell the user forbidden and deny them access. Next one is going to be cross-site scripting. Cross-site scripting, this is an attack on the user side of the site, not on the server itself. Here is where an attacker injects malicious JavaScript into a public place, like a comment section of a web page. When you visit the page to read the comments, your browser sees the scripts and runs it automatically. Now, this script can steal things like session cookies, hijack login information, or even redirect you to a phishing site. So cross-site scripting is one of those things we've got to test for. Modern software is not written from scratch. It's normally assembled by like Legos. Developers are going to use what we like to call dependencies. These are going to be third-party libraries for things like logging, math, graphics, and 90% of modern apps, well, it's going to be running other people's code. This is going to cause a supply chain risk. If your library calls jQuery and it has a known hole or vulnerability, your app now has that hole as well. As the slide says, you are only as secure as your weakest dependency. The next weakness on the OWASP Top 10 is insecure design. This isn't a coding error, it's a logic error. It's a flaw in how the system was thought out. Now, an example here is like a forgot password flow. It's going to ask the username and then maybe display a new password on the screen. The code works perfectly, but the design is insecure. We can fix this with threat modeling, of brainstorming of what could go wrong. Before we write the code, what could we do to build some handrails and prevent people from getting more information than they need to have? So how do we protect against some of these defenses or some of these weaknesses? We're going to talk about the defenses, and let's talk about secure coding to begin with, okay? Because some of these attacks are easier to protect compared to others. And the first one's going to be input validation. The golden rule in application security is never trust your user input. We're always going to use input validation. If a field asks for a zip code, we're going to ensure the application only accepts 5 numbers. If someone tries to type a SQL command or scripts tags, the application will reject it instantly. This is often called the allow listing or whitelisting. You define what is good and block everything else. We can also use what we call sanitation, where we clean the data to turn dangerous characters into safe text. The next protection is going to be SCA, Software Composition Analysis. This is where we use tools to scan our ingredient list, like package.json, and it's going to compare our libraries against known vulnerabilities, CVEs. It alerts the developers saying, hey, you're using this old library, you need to upgrade immediately, or tells us a little bit how we can fix the dependency library so that way we're not susceptible to a certain vulnerability. We can also test our own code, and there's 2 main ways of doing this. We've got SAST, which is Static Application Security Testing. This is the white box method. It scans all of our source code when it's at rest. In other words, it's not running. And it's going to point to a specific line saying, you have a weak password function in line 42. The other method we can use is called DAST, which is Dynamic Application Security Testing. And this is a black box testing. It attacks the running code from the outside, just like a hacker would. And then we'll report, I was able to log in without a password, but I don't know which line of code would have caused it. So both features are very popular. And most of the time when you're dealing with a CI/CD pipeline, continuous integration, continuous deployment pipeline, they use products like Jenkins to do this in the real world. And in that workflow, they may have different tests that they do to every code that comes across that are SAST and DAST code testing. So here's our real world war story for today. And it's going to be about log4j. So in 2021, a vulnerability was found called log4j. It's a tiny logging library used by, well, pretty much everyone in the Java world. The flaw was simple, but very devastating. Sending a specific text string forced the server to download and run malware. It really broke the internet. Defenders spent weeks, I was one of them, just trying to find out where they were using the library. And so the lesson that we learned from this is we needed a software bill of sale, right? We needed a software BOM, which is software bill of materials, sorry. And we needed to know what software we have and where we're using it and what dependencies do they depend on. And if we all had this back in 2021, it would have been easier just to go into our SIM products, figure out where log4j is being used, and apply the mitigation techniques as necessary. Now to wrap up this chapter, it's a little shorter of a chapter, we talked a little bit about application security. And the first thing we talked about was, well, we were talking about shifting left. Security needs to happen early in the design phase, not at the end. We need to know the OWASP top 10, which, by the way, this year was a brand new OWASP top 10, so please go look at it. You can go look at it on the OWASP website. And we looked at some of the basics that we normally see all the time, like broken access control, injection, cross-site scripting. We looked at a few different ones. We learned that some of the defenses are mostly about input validation. We need to make sure that we validate everything that the user gives us. Could be supply chain. We need to know what tools we are using within our environment and what third-party dependencies are they needing, because those third-party dependencies may have vulnerabilities in there that we need to be aware of. And then we also talked a little bit about testing using SAST and DAST between code and runtime to help us find some of the bugs within our systems. All right, that was a quick chapter on application security. So on the next chapter, we'll talk a little bit about logging and monitoring and how we watch for attacks that we cannot prevent. I'll see you for chapter 9.